Thank you for joining us. I am Ariella Ross, Marketing Manager at Friendly Technologies. Today we are with Sean Vanderbilt, IoT Technologist and expert, who will be taking us through the best practices for app enablement with Friendly IoT and Azure. So let's go ahead and kick it off, Sean.
Good morning, good afternoon, everyone. Thank you for joining. So today I'm going to do a two-part webinar presentation here. I've got a couple of slides just to go through to sketch some of the background and present some of the technical material. And then I'm going to jump into a live demo to actually physically illustrate what we're talking about here. So today we're going to be showing you the device to cloud journey and how applications could be constructed in cloud, and we're focusing on IoT Azure today. So we're not presenting Azure and the details about developing in Azure. We're presenting the integration from device over network through device management into the Azure platform. So just sketching some of the background in terms of the IoT ecosystem. Of course, you have devices at the edge. These devices can be connected in a whole number of ways. So typically, there could be very small footprint, resource constraint devices, such as modules built into embedded products. There could be sensors and related. There could be modems, routers, and sort of more feature-rich edge devices like gateways. And each of these pillars represents of different features, functions, and complexity. So from a module point of view, we're typically looking there at ultra-low power type applications, such as in sort of personal trackers operating off batteries. Could be metering applications where 10, 12-year battery life is required. And yeah, so resources are at a premium. Every cent counts, and cost of optimization in that device counts. So running sort of very low footprint code, running the least amount of protocol overheads, and being able to communicate to a top, northbound cloud application. On the more complex side, if we look at gateway type applications, there may be a lot more functionality. There could be some edge processing, fog or cloud computing, and there could be, software over the air pushes of contain applications into gateways, and often these could be multi-service applications. So we could take things like building management or energy management applications, or multiple services. Perhaps you're running some security application together with energy management, and so you need to be able to run more complex applications in the device. It may have multiple interfaces, such as personal area networks, such as 802.15.4, could be Zigbee, Z-Wave, even LoRaWAN, and other type of local RF type networks. Okay, so from a device's point of view, you have all this complexity, different protocols, different networks, and different payloads, different interfaces, and so forth. Right up to, at the end, what you're looking for is representing those devices and their data and all the asset information in an application. And that head-end application could be in the form of mobile phone applications, or web applications, or cloud applications as such. So today we're going to be showing you a little bit about how we construct that application from the device, collect the data, orchestrate that data, and then present that in this case, an Azure IoT environment. How we look at the different parts of this puzzle So you need a couple of things to be able to fulfill this sort of journey. And so one of those in orange here is the device management component. So you need to be able to bootstrap that device securely. You need to then be able to provide the right credentials to the device to be able to register securely. And aside from that, there's the provisioning of the device. There's, in addition to that, is securely orchestrating data, collecting data, ingesting data, telemetry data, asset data, whatever the case may be. And so the device management component performs a lot of that functionality, including things like configuration, monitoring, software and firmware over-the-air updates. Like I said, data orchestration. There could be some event management, orchestration of events and alarms and alerts. So, the device management layer and that element performs a very important function. Added to this IoT equation here is connectivity enablement. So typically, if you're running on a cellular-based network, there may be a SIM or embedded SIM, and there are features and functionality that go around that in terms of managing that SIM, and we term that a connectivity enablement platform. And so, there's functions like provisioning the SIM, activating, deactivating, performing sort of rate control on the data, some billing information, and so forth. And there's a very strong integration element there between that device management layer and the connectivity enablement. There's a lot of interesting use cases that can be derived out of the integration of those two. And just a couple of examples, such as your device may not have a GPS, but you could use the SIM and the network location data. So there we're talking about triangulation of the cellular network and the networks that support that. And you're then able to actually enrich the device data with positioning information. So, and that may be used in, like it could be usage-based insurance type applications, or it could be, maybe security-based applications, whatever the case may be. So that's one just simple example. Others could be just the simple case of provisioning or deprovisioning a SIM and data with an edge device. Maybe there's a theft or some misuse of device. So those functions need to be able to managed very easily. Okay, some of the other aspects to this is, so once you've got all this data out of these edge devices, you want to do something with this either in an application or a cloud application. So that's where we'll talk a little bit about the analytics and being able to actually construct analytics outputs based on all this data that you're collecting. So there are a lot of good frameworks for that. There's some off-the-shelf frameworks, like Alteryx is one, but many customers like using the cloud frameworks, whether that's Amazon or Google or Ali, and in this case, we're talking about Microsoft Azure. So there's some good tool sets on the Azure cloud for that. And then finally, we want to be able to actually represent and present this application. So presenting the data in a legible format, a graphical format, a visual format, being able to construct things like rules engines, being able to enrich the data, process the data, format the data, translate the data, and to do functions and actions based on conditions and alerts and events. So if certain conditions happen, you want to be able to switch things on or for whatever the case may be. So the application here is important as well. So, and this is often very difficult for companies to sort of wrap their heads around about how do they actually put all of this together. Devices, connectivity, the network, management of all of that, and bringing and ingesting that into an application, and doing that cost effectively and securely as well. So I just need to highlight a few things. When we're talking about device management versus an IoT platform, there are 1,000+ IoT platforms on the market, open source, commercial applications as well. And many of the generic IoT platforms out there, they're very good at that visualization element, like the ingestion of the data and the formatting of that data. But they're lacking in a number of areas, such as those more complex functions, that, bringing in management protocols, performing configuration and control, and device management of the edge device, even things like firmware over-the-air updates, and doing that in a uniform or an open standard. So one of the solutions for that is the Friendly Device Management solution, and including the enriching functions, for example, being able to do the data orchestration, collection of data, and being able to provision that to upstream applications. So typically a solution like that would architecturally look like this. You'll have edge devices in the field across all sorts of different networks, whether they're IP-based networks, so it could be cellular, WAN, LAN, wireless, whatever the case may be, or even in the cases of non-IP, are also supported. And LoRaWAN is an example of a non-IP RF network, but others in LPWAN could be the NIDD, so it's a non-IP data delivery function within LPWAN, cellular LPWAN, so NB IoT Cat M1 supports NIDD, and so that would potentially be used in a module or device that requires ultra-long battery life, that do not support a TCP IP stack or IP stack as such, where every bit of RAM, flash, and a microprocessor power is of optimum need. So in a non-IP fashion, we're able to connect those devices through our management platform, including many of the IP-based protocols. So typically, when you're connecting these edge devices, they may support different protocols. The ones you're really interested in the IoT space, I'd say the two big ones today is lightweight M2M. So lightweight M2M, machine to machine, and that lightweight M2M is a de facto open standard by the OMA, and the OMA is one of the standards bodies. And so lightweight M2M is probably now, I think it's about almost 5 years since the version 1.0 was ratified. So it's well matured. There's a big ecosystem around lightweight M2M. Most of the cellular modules today in NB IoT Cat M1 support lightweight M2M. And there's a rich ecosystem around the clients, the modules, and the management systems. And the other sort of big one is the enhancement of the older broadband standard, which was TR-069. That's evolved into the IoT world to TR-369 USP. And so USP, Universal Services Platform, allows for the IoTification of broadband devices, but it could be gateways with multiple services, and so you can push sort of container applications down to those sorts of gateway applications using USP. And there's a very good, rich integration into IoT frameworks using USP. Once you sort of have that together, these are off-the-shelf components. You're then able to construct and select that data for ingestion into upstream applications, such as you could be pushed into a cloud data lake for further storage and processing, and potentially running some analytics on top of that, or you may want to run some AI or even machine learning type applications for example, in the cloud. All of those integrations are available there. So what we're going to be showing you today is we're connecting a device at the edge using one of the standard device management protocols through a device management platform. In the device management platform, we are performing a few little functions. One of those is the data orchestration. So where we choose which devices and what asset data, what sensors, what particular telemetry interfaces we're interested in, and then we frame that in terms of the collection of that in real time, and we provision that into an upstream cloud application. And I'm going to be showing you how this is done in Microsoft Azure. And there's a bunch of different cloud protocol streams that are provisioned and utilized, such as the big ones are Kafka and AIM-QPS and PubSub. Those are the sort of big cloud hyperscaler cloud environments, and they support those protocols. But others could be just integrating to the REST API, or even using things like RabbitMQ or MQTT to provision data or ingest data into a cloud application. What we're talking about in Azure is, and you'll see most of the clouds have similar functionality, but Azure have built up quite a rich feature set in the device twin. So what we're going to show you now is we bootstrap and register a device into the management system. It automatically, dynamically creates a device twin in Azure IoT, and that device twin represents sort of the digital copy of that physical device in the field with all its desired and reported parameters. So the reported is essentially what the device is providing to the system, and desired is what the system would like the device to update its particular parameters to. So, and there's a few other features supported there, and we'll cover that shortly. Now, in the end-to-end integration there, what we do is we also create an entry into the device provisioning server, the DPS, and in addition, we create a device template in IoT Central. So that device template defines the interfaces to the device and how to interact. So whether you want to do a firmware update, you want to reset the device, or you want to control the device or update the device. So those templates created in IoT Central allow you then to, when you develop your application, to interact with that device and how to interact with that device. This gives a little bit of detail around how that process and the flow works. But any IoT endpoint, when after bootstrapping and successfully registering, securely registering with the server, the various entries are created in IoT Hub as the device twin, and of course the DPS and the template in IoT Central. What I'll do now is, by example or demonstration, I'll give you a quick view of this. So just if you are interested, we've covered a number of topics in previous webinars, and so I do encourage you to go and look at some of the YouTube content, but so I'm not going to go into demonstrating device management and all the functions around firmware updates and all configuration and monitoring and event management and all of that. But just suffice to say, we have some online demos, and these are available. Just make contact with us, and we can set something up for you. But what I'll be showing you is our online demo system today. So, so what we're doing is in our this is a cloud-hosted device management system. So maybe just sort of a couple of little features to show you. It's a multi-tenanted system. You can create as many tenants in the system as you would like in a hierarchical tree structure. And so you can allocate devices to a tenant, you can allocate users to a tenant or subtenants, and and any sort of settings and configurations also allocated to the tenant. So the tenancy can also be fed through into a multi-tenanted IoT application as well. Okay. So what we're going to be showing you is, as I said, we're not going to demonstrate all device management functions here, but we're going to be showing you what we're doing with a particular type of IoT device. In this case, we've got a sort of a generic water meter here as an example. And this could be a personal tracker, it could be any other sort of device. Now, what we're doing is we're providing water metering data into the system here, but how a device connects to the management system, device management system, follows this lightweight M2M protocol. And so, for example, there's sort of a lifetime, let's call it a keep alive. So there's a sort of a lifetime update. So the device provides information to the server on changes or updates from the device, and the server records that information when it arrives on that lifetime period. So an example, this particular device's lifetime is 60 seconds. Okay. So the information that is represented here for this device, so we're looking at, for example, if we look at the device is providing temperature, in one case, it's providing pressure, in another case, it's also providing a few other bits of information. You know, it could be providing information around the cell connectivity, APNs, in this case, transmit, receive packets, and so forth. Cell IDs, you know, APNs, RSSIs, and so forth. So there's a whole lot of information provided by the device. Okay, so from the management system, we perform a orchestration function. So we set up a okay, so first of all, for this demo, we just have 3 devices here to show you as an example here, but this could be millions and millions of tens and hundreds of millions of devices, and the same functionality applies here. So what we do is we configure a monitoring task, and so basically what we do is we set up a task that says, you know, and based on, you know, a whole bunch of manufacturer devices, part numbers, and you can nest them. You can have a whole list of different manufacturers, a different part number, different products listed on this particular monitoring task. And each one, you may be choosing a different set of information that you are ingesting from this device. Okay, so the monitoring task here, if you're familiar with lightweight M2M, relates to the observe and notify events in the lightweight M2M protocol. So we're actually creating an observe event for that edge device. So we've selected a bunch of devices, and we've said we're interested in their battery level, maybe the memory, its pressure, its temperature, and maybe its RSSI. So that's of interest to us. What we want is this task to run forever, or you may choose a certain date and time when this ends. So that could be the end of January next year. In this case, we want to say, give us an update every minute for these particular parameters. There are also options of setting thresholds, so it could be an average, min, max, a delta change, and so forth. So various criteria can be set for those parameter updates. And now what happens is, once this monitoring task is set up, the observe events from the devices then start being pushed from the device to our system, obviously using the notify events. So all of those notify events come in real time, and that information gets stored into a real-time database. So we have all this information coming in. Now, before I show you what is happening with the sensor data that is coming in here, and these ones, the RSSI, battery, memory usage, pressure and temperature values is what we're interested in. So before I show you what we're going to do with this data, I just need to explain to you one or two things in the actual setup. What we do in lightweight M2M as a protocol, we're able to set up secure bootstrap and server security settings, so a bunch of different security schemas and even application level security called OSCORE, which is supported in lightweight M2M 1.2. So this is all supported in our platform. So you set that up, set up your bootstrap. This is sort of a once-off configuration, and then all those devices would be connecting through bootstrap and registration securely. Now, the next thing we do is based on your tenant. So you may have multiple tenants in the system. Each tenant can have their own Azure, the Azure IoT Hub connection strings. So this is a particular setting. and also the IoT Central Plug and Play API connection string. So once these two are set up, so if I jump into a subtenant, now each tenant can have their own configuration, okay? So this tenant has its own configuration for the IoT Hub and for the IoT Central connection, okay? And you'll see this is just a water metering demo application in Azure. So once you've set this up and you receive these API tokens and URLs from your tenanted Azure environment. So you'll have your own Azure account, Azure IoT account, and you will retrieve these APIs and the connection strings from your Azure account. Okay, so you set this up on your tenant. Once that's set up, then all the devices that are allocated in your specific tenancy will go to your Azure tenant. So you can load up multiple subtenants in here, and each subtenant can have their own connection to their own Azure account. Now I'm going to just jump into, I've logged into the Azure environment here, Azure IoT, and there's a huge amount of functionality here. And like I said, I'm not here to demonstrate all the Azure functionality, but I will be showing you in the Azure IoT environment, we create a IoT Hub. So we've created one here called FTL Demos. And in the FTL Demos IoT Hub account, we can actually get a high level bit of information about how many devices are connected, the sort of message throughput and so forth. So now within the hub, we want to look at the devices that are connected in the IoT Hub. And remember what I said is we create this device twin. It's a digital representation of the physical device in the field. So if we just have a look at one of them, so let's look at this serial number over here. And we look at the device twin information for this particular device. We will see desired properties and we will see reported properties. So these map what we're getting in our management system, and we're mapping the digital copy in the physical device. Okay, reported is the information that the device is sending us, and desired within the device twin here, the desired is you may want to make a physical change to this particular device parameter. So when you go and make a change to parameter in desired and save and send this to the device, then that particular parameter is updated in the device, and the device comes back with an update to the reported property. Okay. Now, within the device, the further integration here is being able to do direct methods. So these are all reported, these are all supported. In addition, you can also send message to device as well, and this is fully supported in our platform as well. Okay. Now, so once you have the device twins represented in IoT Hub, and this happens dynamically and automatically. So once you've set up your connection string in the external connection through these particular configurations within your tenants, and those devices register with the platform, they're automatically dynamically created in your IoT Hub as well. There are a couple of options when you're setting up the connection strings here. There's a few configuration options there. But now, so these device twins are created. In addition, remember I told you the full plug and play also involves, we can't only use the desired and reported properties in a device twin here in the IoT Hub, but we also need to know how to interact with that device, for example, updating firmware, making a configuration change and so forth. So those parameters are set up in the actual, let's jump back one step here. Yeah. So that is set up in, let's have a look over here. We've got a bunch of devices reported. And if we look at our particular devices that are created within the IoT Central, these particular templates are then defined. So you will then see a template operation on each of the parameters within the data model of that device. So there are some of the functions here include, for example, rebooting, reloading, restarting, and even updating firmware and so forth. So there could be, like, here's a factory reset function. And so, all of these functions are exposed in this template. The template is dynamic. So any new device that gets registered automatically creates a dynamic template that matches the features and capabilities of that device. Okay, so with the device template that has been created, what we now will look at is creating a dashboard. So we have created a dashboard here called Water Metering Demo. And an example here is, if we have a look at, if you're familiar with Lightweight M2M, there is the object IDs and resource IDs. So we're looking here at a particular object ID. This is a pressure reading. So object ID 3323 and the resource ID of 5700. So we're now actually getting live pressure readings from those IoT devices in the field. Okay, and this is happening in real time, and it is dynamic, and it gets updated automatically. Okay, and this is the dashboard application here. As I said, I'm not here to demonstrate all the Azure functionality. I'm sure some of you know how to develop Azure IoT applications way better than me, but what I'm showing you here is the ability to present all these devices with their templates and operations in the IoT Central environment here, and you can now actually go and create your own applications. Okay, and it is as simple as within the dashboard, you can go and choose one of your widgets that you want to go and create. So, like, you can see there's a map object here. So if there's a physical location for the device, it'll be represented in a geolocation in the map. Anyway, you choose a widget here and choose your inputs. So if we just have a look at the settings of this particular chart that we've created here, we've chosen a couple of parameter or configuration options for this chart. What sort of time period you want the chart to display at, what sort of interval, 1 minute. But we're also choosing the devices that we want to represent and display in the graph, and what actual telemetry parameter we want to actually use, and whether we want that as averages, sums, minimum, max, and so forth. So in any event, that's all configuration options, and this is all standard functionality within Azure IoT and IoT Central here in specific. Okay, I think, so for example, you could create widgets here like updating versions. So this could be a firmware over there, update function. So, if we had to physically operate one of these, we're in the edit mode. So let's save this dashboard. We've now finished editing. And if we went and updated a version, we may want to actually sort of run that update function on that particular device. Okay. So now further to this, you can start making use of the rest of the Azure IoT framework. Again, I'm not here to present all the features of Azure, but you may want to run some of the analytics tool sets here based on all the data that you're archiving and storing. You may want to run a couple of rules. You may want to run some jobs. A job, for example, you may want to set up a mass update of your devices. So practically, you can utilize the end-to-end I've shown you now to zero-touch provision a device. So a device gets shipped to a customer, gets switched on, gets connected through the cellular network, as an example, automatically bootstraps, then registers with the management system. The management system creates the entries in Azure IoT Central based on the configurations that you've made. Now you can start showing, you can start doing asset management. So you may have thousands or tens or hundreds of thousands of devices in the field, and these devices are being provisioned to customers. They could have geolocation provisioning on installation, and there may be a installation or configuration during installation, or the customer may install it themselves. Whatever the case may be, you can do asset management in the Azure environment here. You can start managing that fleet. So, for example, creating a job, you could maybe push the latest version of firmware to any of the new devices that are connected to the system. And you can create other more complex jobs here as well, including, like I said, taking the data that's being ingested here into this environment, and perhaps you want to save this data into a data lake. But, so if you're an Azure developer, Azure partner, or you have a IT department or partner that's developing IT applications for you, this is their world, and you would be able to develop your IoT application in this environment. Okay, I think we have reached the end of this particular webinar.